reach for the best of myself. It's all even if I fall, but you stay. Don't stop. Yeah. Oh, oh, yeah. Tried so hard, stumbling in the dark, learned how to see. You already saw. You're the one to blame for the fact that I can't read all the best of myself. So you should.
Oh, you guys have added a lot of sessions.
Still wonder how. Yeah. You always make it right. Maybe it's all changed, but either way, you showed me how to reach for the best of myself. It's all you showed. 'Cause even if I'm gone, just you. And through the dark and cold, I know it's all that you love. Myself. Yeah. Oh, oh, yeah. Tried so hard, stumbling in the dark, learned how to see. You already saw. You're the one to blame for the fact that I can reach for the best of myself. So you should.
Hello, everybody. Welcome to De-risking Agentic AI, a practical framework. My name is Alexandra. I will be your humble webinar moderator for today. It is my distinct pleasure to introduce Steve Brodston. I'm very excited to hear what he has to say. I'm sure all of you are as well. Just some brief information about how we're going to operate today's webinar. If you have anything that you would like to share, it is warmly welcomed. However, we are going to ask that if there is something that you want to share, just raise a hand and then I will communicate with you in the chat. And then in moments of pause, Steve and I will work together to answer questions in real time. So, we will be able to have people come on and off mic at their comfort and leisure. But just, in those positive moments. Other than that, please, once again, do let me know if you have any technical issues or any questions in the chat. I'm always happy to help. And at the end of the session, before you leave, please be sure I will send a link to a very brief, encouraged feedback form to let us know how we are doing and give us some feedback on ways that we can continue to improve across the board. And with that, I'm very happy to introduce Steve Brodson, and enjoy your webinar.
Thank you very much. So I'm going to share my screen, and let's make sure it comes up. You guys can see that, right?
Yes.
Good. Cool. So I'm Steve Brodson. My background is I've been a security architect for more than 20 years and a consultant. I am focusing now with my own business on AI cybersecurity consulting, and also have some very interesting side projects going as well. So I'm going to be giving a weekly series on cybersecurity. I don't know how long it'll last, but I've already been working on content for the future sessions. The next week we'll be talking about securing or secure vibe coding, and we'll be focused on Claude Code. There will be, I have a future session that I've been working on prompt injection, both showing it from the offensive perspective as well as from a defensive perspective. Some of those kinds of things. So please stay tuned. There's some really cool stuff. For this one, this topic kind of comes together. It's not gonna, I'm hoping that it's not going to be as deeply technical as some of the other sessions. It's really, my intention was because this is sort of a convergence of a number of things that I'm working on. I wanted to bring it to the table. So what are those things? Well, one of them is my capstone project for CIO certification, which is really going to be focused around governance of an agentic mesh from a business perspective. And then the other one is that I'm leading an open source project called Aegis that is focused on building an observability and policy layer that orchestrates various security tools with the focus on technical controls around agentic AI and especially mesh. So with that, let's jump into this. So one of the things I think you've heard, basically, if you read Gartner, you read a lot of the industry. I think every year there's sort of a theme of the year. Last year's theme was generative AI. I think you're now getting to the point where this year's theme is agentic AI. And we've already seen agents out there in the world, both from an open source perspective with things like OpenClaw, which was my last presentation, and then things, it's become mainstream. There are commercial agent applications out there on the marketplace. It is far more common. Claude Code, in fact, has just, as of the last update, implemented a feature called agent swarms, where it is using meshed agentic AI to build code. So this is a very real topic, and it's something that I'm trying to be timely. Now, one of the premises here for this conversation is that the world is going to be in a situation where well, let me take a step back. As a chief AI officer, if you went into your customer today and they were saying, yeah, I want to build a bunch of agents, I want to have them all talking to each other, I want to have them working together collaboratively, and I want to come out with a result. If you're like me, right, you're like, whoa, let's put the brakes on that. Um, but my premise is that the push for that, the push for the ever increasing productivity, is going to actually arrive enterprises at that result. Enterprises are going to be doing agentic mesh solutions. They already are. And so as a chief AI officer, this is important to recognize because chances are you're going to see it, especially in the next 12 to 18 months. And I think that just saying no, put the brakes on, might not be the best approach. That while it obviously has very serious risks, which we'll talk about, I think that the rewards of it are going to prompt some of our customers to want to opt for it. And so we need to know how to both consult around agentic mesh and how to really talk about from a technical perspective how to secure it. So I'm not going to get too deeply into the technical side today, but we'll talk more about a consultative approach. Now, for those of you that were on my last one, my last presentation, I demonstrated my OpenClaw bot. It's called blastr. That project, a personal project, has evolved in the last couple of weeks. It's now blastr Junior. It's now on a different product that is called Bastion Claw, which incorporates some security features and such. And it's now a multi-agent or agentic mesh framework. So what I have is I have a main bot named blastr, or actually in this case Junior, because I haven't migrated it over yet, and it'll then become blastr again. Um, but blastr has a delegation capability. So blastr is now an orchestrator, and his role is to orchestrate all of these other sub agents that are busy taking care of different aspects of my professional life. And what I found is that while this is an immensely engaging sort of personal project, it's become far more than a hobby. It really does save me a bunch of time, or will I haven't had to invest some time in the building of it, but it's going to save me some time. But what you can, but the trick is that I've broken down my subagents by function. So what you can see here is that I have everything from a researcher and a scribe. I have an artisan that's responsible for building graphics and graphic presentations. I have my forge, which is my coder. I have um, I have different functions addressed. So my connector that handles my CRM, and it's responsible for managing a bunch of my my networking connections in the background. It's all kind of triaged and managed in the front end by the triager, and it's all watched from both a security and a sprawl prevention perspective by the watcher. Now, all these connections may or may not be occurring at any given moment, but the fact is that it is this sort of meshed architecture, that I've just found very fascinating, and have now started to try to dig into how do I secure this. So going back to the other piece, right? When we look at AI, and especially agentic AI, we want to measure the risk. We want to analyze the risk. And while it's a bit of a simplification from what a true big security architect would use, it's a very useful framework for a chief AI officer for understanding cyber risk out of an AI organization, to really break it down into three things, right? The three things that really drive the risks of AI are: number one, the fact that it can act autonomously. So it can go out and execute actions without a human in the loop. And so that's one factor. And the more autonomous that an agent is, the more the risk, the higher the risk. The second piece is the fact that it has access to data, and that data can be more or less critical and sensitive. So if, and when it has access to data, there's always a risk of corruption of that data. There's a risk of disclosure of the data. The old CIA triad, right? Confidentiality, integrity, availability. Those are all data issues, and those are all impacted when you have an agent that has access to your data. And then the final one is the access to the outside world, right? Because there you have an agent that could take autonomous actions that could reflect poorly on your reputation. It could disclose data. It can do all kinds of things as an independent actor that we need to look at. And when you start evaluating in these three dimensions, you can really figure out, it starts to become a lot clearer what is the risk of this particular agentic, of this particular implementation. And so now here's the trick. So every agent can be evaluated in these three dimensions. But now let's think about a scenario where you have multiples of these agents all interacting, all working together in some with each with its own autonomy, access to various data, and access to the outside world. So what you can see is that the reason mesh gets really scary is that you get this exponential increase in risk because you're multiplying all of the risk factors. So what we, so that's something that we need to think about. And in fact, this is not just a hypothetical problem. So Salesforce Salesforce has built some mesh agentic capabilities into its product. And it's really, really cool. If you are a Salesforce user, the stuff that you can automate with it is incredible. So you're able to take advantage of multiple agents all working together in different forms. Now, back in December, there was an announcement by a Frontier Lab researcher that found a way to exploit that agentic architecture to exfiltrate data from Salesforce. And what he did was he was able to, by providing a compromised record, he was able to prompt inject the low end sort of front end agent that was the gatekeeper, use that to influence the much more privileged agent in the background that was doing a lot of the work and had access to a lot of the critical data. So, yes, it's a more complicated hack than just prompt injecting and one thing. But what happens is in a mesh agent system, you can really get this unhealthy cascade that leads to a catastrophe. And so how does that work? Well, just in the case of just as demonstrated by the Salesforce case, right? You get an initial compromise on agent A. And once and one of the facets or one of the characteristics of prompt injection at present is that at least before the very latest frontier models, when a model was prompt injected, it usually stayed prompt injected. So in other words, once I was able to jailbreak a model, I owned that model. Now, in the most recent versions of ChatGPT and Claude, there's actually a learning mechanism that has been brought into it, and you get about from what my information is, you get about 5 to 7 prompts before it starts reasserting itself. But still, right, that could be enough. And so in this case, right, you get your initial compromise, your initial jailbreak. And when I go into prompt injection in a few weeks, I want to show you how easy it is. It's amazing how vulnerable this stuff is. And then you get lateral delegation. So you get basically passing, you use the one compromised agent to compromise a different agent. And one of the things that you find is that depending on how that thing is jailbroken and what the prompt injection was like, you can really gain very, very comprehensive control over the activities of an LLM, even one of the frontier model LLMs. And so what that does is that, so once you've made that initial compromise, there's a very real risk you've got a live insider that you've turned inside that environment. And now you can use that to start moving laterally. And then finally, then once you move laterally until you find some sort of something that's touching sensitive data, that's touching the functionality you use, then you work through your privilege escalation, which notably is easier because the communication isn't coming from the outside world, it's coming from an agent that is already trusted by the agent that you're talking to. And then finally, there's the data exfiltration, right? How do we get that data out? Well, we now have an agent actively working inside the environment, that we can instruct. So we're able to instruct it to exfiltrate that data. And the critical piece here is that no agent has violated its own rules. So in this case, you get a picture of how important a governance structure is. Now, again, right, the best policy is to probably not allow some of this agent to agent mesh. But again, right, I think that this stuff is coming, and I think that it's inevitable. And so we really need to really figure out how we're going to live with it, how we're going to move it along. So now going to, okay, what do we do about it? And there's been a lot of thought. There's a lot of tools. One of the things that my open source tool responds to is that right now the security tool market is incredibly fragmented. So you have tools that take care of one facet of the problem, and some that are even do a pretty good job at that. But there's nothing that puts it all together. And so so if you're interested in building, an overall technical governance architecture for a customer, and this applies to just simple single agentic AI as well, there really is, the options are somewhat limited. You end up having to put together a group of tools to make things work. Now, there are some of the commercial tools that are getting closer. I mean, I think Microsoft Security, if you're in a Microsoft environment exclusively, is getting there. I think you've got, for example, groups like CrowdStrike or SentinelOne that are really building comprehensive ecosystems. They're getting there. They at least have the tools to start to build that. But for the most part, those tools aren't out there. So that's why my project, that is a policy and observability layer that orchestrates other tools. So it's not doing the actual controls in the environment. The user will end up picking his or her control, specific tools, but those will be orchestrated, and there will be a common policy across the top. And that's sort of what I'm working on. But the real innovation is that because of the nature of AI, right? We've talked a bit about in the past about how traditional AI cybersecurity doesn't work real well. There or has some weaknesses in terms of defending AI. How do we deal with that? And so the answer is that, we treat these, if we think about these agents not as programs running or applications, but if we think about them as actually agents running in the environment, right? We could now apply an analogy from business that's been running for, I don't know, lots of years. So we start to, so my model is built around applying human resources principles to the concepts of cybersecurity, right? Because really what we have, if we're looking at these as autonomous actors within the environment, we really need to, you're not going to be able to control every possibility, especially because a truly autonomous agent will have the ability, to be persistent and to continually probe your defenses until it finds a gap. So the question is, how do we, instead of trying to block all those possibilities, how do we run with that and just sort of, sort of like jujitsu, right? How do we use that to our advantage in building it? And again, right, the just as a reminder, right, that the issues that we have from a traditional cybersecurity perspective, AI is non-deterministic. You're not going to get the same result every time. The surface area, the attack surfaces are bidirectional. So we don't have to, we're not just worried about threats out there in the environment, we're also worried about threats that originate with the agent itself. And then finally, there are, in the AI world, there are unsolved problems. Prompt injection being the absolute biggest glaring one, that are things for which we don't have answers at the moment. And hopefully that's improving and we'll get there. It's a little harder to prompt inject the latest frontier models than it was to go to some of the prior versions, but it's still something you can do. All right, so let's talk about, what does a governance model look like? And this is generally a best practice for for AI in general, but in when we're looking at agentic AI, it's especially important. And so what I've tried to do is tried to break it down into some categories that kind of make sense, and that give you kind of a guardrails in terms of how you can how you can apply it, right? So the first one is just more or less traditional governance controls. And these are going to come from the interfaces with people and the operations around AI, right? Human in the loop thresholds. And as I pointed out before, right, human in the loop, we aren't going to be able to just approve every transaction, right? Anybody that's used Claude Code, for example, it pops up saying, do you want to, you're going to accept this change about 15 times over the process of building something. And you just get into this, yes, yes, yes. And that's not true governance. So what we need to do is we need to think about governance in terms of being a manager rather than being a micromanager. In other words, so if you think about from the HR perspective, right, a manager is going to set the goals or set the objectives, and is going to give each of his or her reports a set of KPIs that they need to meet, and then is going to observe what they're doing over the course, and then is going to evaluate them against those APIs. So what if we start to look at it from that perspective? It becomes, we don't have to get in the way of every transaction. We can now, it becomes a more workable load for the management layer. It also increases the efficiency of the layer beneath. And so that's one of the areas. So the second area that we talk about is architectural guardrails. And this is really the application of traditional cybersecurity to the problem of how do we prevent AI from roaming and doing whatever it wants. And so, again, I mean, I know most of you are probably not cybersecurity experts, and some of these things would require a bit more explanation. But what we're really talking about here is traditional cybersecurity concepts, right? You have to authenticate. Better if you have multi-factor authentication, right? You have to, we want to put in controls, segmentation controls to give us both an ability to see what's happening as traffic crosses various thresholds, and also to prevent things from crossing those thresholds that shouldn't. So that allows us to set up to use a system called zero trust, which really is a paradigm around, hey, every individual, we're not just saying that anybody inside our firewall is trusted. We're actually going to, we're going to say you're not trusted until your behavior and your authentication show us that you can be. So that's the piece. But in the specific technically applied to agents, right? This is all about things like tool whitelisting. So agents agents are configured to use tools. That's how you give them access to different things. For one of the controls that I was talking about 2 weeks ago when I talked about my OpenClaw was that I build all of my own tools, and every tool has a Python component and then a Markdown file that instructs how to use that Python component. And I build one of those tools for every access, every application or data storage thing that needs to be accessed that is outside of the sphere of influence of my agent. So for example, when I wanted to give it access to Airtable, I built a Python stub that exposed the various Airtable APIs that I wanted to use. And then I wrote a Markdown document that told the LLM for the agent how to access those things. Now, tool whitelisting is important because in an agentic environment, you want to centralize for efficiency. You want to have a centralized tool store. And you don't want a rogue agent to just go off and have access to everything. So we tell the agent exactly what it has access to. We also can implement kill switches, and these are part of the architecture. All right, so then we talk about the security and the threat surface. And this is really much more about those attack surfaces and and really identifying and mitigating where our risks are and where they come from. So here we really are looking at prompt injection, right? I know that prompt injection is not something that I can entirely control. So how can I isolate agents from one another, limit privileges, contain to prevent what we call the blast radius of a prompt injection attack. If somebody can compromise one of my agents but can't get any further, that's at least better than having it cascade through my organization. Um, privilege escalation, always an issue. Supply chain is so important, right? All of the things that we do in our, are built around tools that we are bringing in from the environment. The actual number of tools that we're actually building is very low. And what we're doing is, so you'll notice when you do vibe coding, right? You're bringing down Python, you're bringing down Node.js, you're bringing down Rust, and those are all things that are your digital supply chain that you're bringing something in that might have something bad in it and associated with it. So there are ways we can control that. And then finally, economic governance. And this one is interesting because it's really not necessarily a security issue, right? If you notice all of the explosion of people out there installing OpenClaw and, oh, this is so cool and all this, and 2 weeks later you start seeing all these posts about, oh my God, it was $4,000 last month. These tools are, for the first time, I think, the cost of tokens is becoming an extremely real constraint. And so we need to build governance around that as well, how to use that. So if I start with these 4 pillars as kind of an analytic engine, and apply the sort of managing agents according to HR principles, where does that get me? Well, so now we look at you look at some of the things you would do as a manager, right? Hiring, right? Well, are you going to hire somebody off of LinkedIn with just a video interview? Or are you going to go and do some vetting first, right? We need to do vetting on anything brought in. That's both the digital supply chain, and that's also just the agentic component as well. Anything that's coming in, we need to look at. Access control, right? Employees are access controlled regularly. I don't, if I'm a, if I'm given permissions for what I need to do my job. Physical access to buildings. I usually have a swipe card. I only have the access that is what's necessary. the same aspects apply to the, to agents. Now here's something cool, and this is something that is a little more challenging to build. But it's really, but I think I think this is sort of an innovation you don't always see, right? So the supervision is really important. And when I'm talking about supervision, we've been talking about observability in cybersecurity for a long time, right? Observability is looking at knowing all the time, what is that agent doing? What is happening there? What's going on? Okay. Now, here's the trick though. When we start applying the human resources lens to this, we start to understand that we need to be behavioral in our supervision. We need to be our analysis. An action by an agent just normally may not be a fully, it could either be normal benign, or it could be, a bunch of normal benign steps that add up to being something really dangerous. And so our supervision has to not just have visibility into things, but it has to constantly have that analytical capability to understand the behavioral trends and to see when something steps out of it. And likewise, right, we have gate points where we perform our performance reviews. Performance reviews against pre-established KPIs. And this is something that people don't apply to cybersecurity very often, but it's something that we're trying to implement that I think is, and I think having those performance checkpoints is both a check on making sure you're getting towards your ROI, as well as a cybersecurity and a cybersecurity checkpoint. And if you notice, when I had in my agentic the agents that I built for blastr, one of them is called the Watcher, and it sits there in the background and it does all this analytics. And then finally, right, escalation. So we want to have regular, instead of having to have the human make every decision, we want to have automated checkpoints that get escalated to the human upon certain conditions. Some of those might be behavioral coming out of the supervision. Some of them might be just hard tripwires that if something happens, this is something that stops and it goes to the human for approval. But those, but those things are enforced at the resource, not necessarily in the agent itself. Finally, you have termination. And so look, if I do something that my employer doesn't like, I'm going to get fired. And likewise, we got to have the same capability for an agent. And so one of the characteristics of this, Watcher has the ability to send me a text. It has a big red button. It says kill this process, and I hit stop, and it stops immediately. So this is what I mean when I talk about bringing HR principles in. Okay, and then the other one here is sign off. One of the things that you see in meshed, in effective governance of mesh agentic organizations, is that there has to be an autonomy, or there has to be a hierarchy, a tier, that that I don't want every agent running around as its own boss, because as you can imagine, right, that's going to get really unscalable. blastr right now has 11 agents that act autonomously at different points, right? That's probably more than I would like. Ultimately, I would like to have a sort of a supervisor or for various functions. The difference is that in my case, the subagents are really broken down by function, and so each one has its own function. So that really is, that's mitigated a little bit. If I had a whole slew of agents working on a single function, I really want to be able to have a supervisor bot that's really that's really running herd on that. But again, right, so the way we tend to do that is through is through tiers. The descriptions on this slide aren't that great. When you think about it, right, tier one being the least the smallest area or scope of operations, fully supervised, so hits the edges of that scope and it's escalated right away. Tier two is given a broader approach. Probably that's your sort of your manager level. Tier three is really only the orchestrator, and you really need guardrails even within that. So I really want tripwires to tell me when the orchestrator's doing something I don't want. So just to sort of start to wrap this thing up, right? Oh, I'm sorry, this is the data privacy. Basically, data privacy is still a really critical component. It's something that we know that we need to focus on. These are some pieces about how do we control data privacy in a multi-agent mesh. And here's the trade-off, right? When you have multiple agents working on a problem collaboratively, they all need access to some shared component. Not only that, but when you look at the ways that agents communicate today, right? There are some better and some worse, but a lot of it is done through something called inter-process communications, which is generally done through file exchange. So even those files can be the data, right? But you need to look at what is the scope where the agent has access to? How is that data being transferred? Are we transferring it? Are we just creating one big folder and every agent's putting stuff in there so everybody has access to the same stuff? Or how are we segmenting that? And then the third one is what it remembers, right? We've all talked about context window, and it's really when you build, there are all kinds of memory systems built on top of context windows that can give agents very long memories. You really have to pay attention to that as well when you're looking at data privacy. And so, it really comes in, well, what are the controls, right? Classification of your data. Make sure that your data is tagged and classified, and that you have good instructions for agents. What are they permitted to use? What are they not permitted to use? And we need to also have observability over that, because there are times when it's not unheard of that an agent will ignore its instructions. Model routing where you're sensitivity aware, right? What's the tier level of the agent? You don't want to have a tier 3 agent that's able to, if you've got communication between your tier 3 and your tier 1, you've got to be, that's a place to really tune into. You really want that communication to be through the chain of command hierarchically. So I mean, I'm not going to go through all of these, but these are things that I invite you to study and to ask me questions about, because these are things that I think are going to be part of the governance landscape very shortly. So just to wrap it up, right? Agent mesh is your largest insider threat. Agent mesh can be immensely productive, and there's really good reasons to go to it. From a productivity and ROI perspective. It's also scary as hell. I mean, this colluding agents one, right? I mean, when you start thinking about some of the social experimentation that took place on things like Moltbook, when people had their Claude agents out on the internet collaborating, that's a very real threat in this environment. Negligent agents, right? Agents will do their best to follow your instructions. That doesn't always mean that you're going to get exactly the result you want. If your instruction isn't comprehensive enough, then the agent goes and makes its own interpretation, especially acting autonomously. If it's, there are times when it gets overloaded and it does things outside. There are even times when it interprets something that you said way differently from how you said, from what you intended. So negligence is big. And then obviously compromised agents are a problem. Okay. So I guess I've used a few too many of these, slides, but let me just go through. The blastr experiment was has been an incredible experience for me. It's really, really important. I have learned such great stuff from doing it. So I mean, these are some of the things that I've learned, right? Um, I think I did it in a fairly smart way. I started very slowly. Can I trust, and I made it very clear, even talking to blastr, right? I've got to trust you. I've got to trust you to do this. And we talked back and forth just casually about what it meant to make me, what my trust meant and what I expected from him to earn to earn more trust. And what was interesting is because I've built this comprehensive memory system over and above what OpenClaw had and now what BastionClaw has, he remembers this stuff. And it does change his decisions. And it's amazing. It's really an interesting thing to see. So because he wants to please me, as all AIs do, he has actively worked toward building that trust with me. And as a result, we've been able to build more and more different types of functionality and more and more autonomy. Tool permissions are just critical. Okay, so every agent in my structure has I can specify what tools it's allowed to use and what tools it's it's a whitelist. These are the tools you are allowed to use. Now, I actually had to contribute to, I actually did pull requests to the OpenClaw project because it didn't really have anything. It was very insufficient. Even the BastionClaw project still has an outstanding bug that the project's owner has asked me to fix, that allows me to make this control. Observability, making sure that you build it into the fabric of what you build. So for me, it's in that watcher agent. And building that was just a complete lesson in how to and how not to do observability. Cost, right? How do you control the cost of this stuff? The OpenClaw will not run on the Claude Max plan, which would have natural limits. You have to pay for tokens. It can go crazy. And what I found was that over time, the way that its memory structure was built, it was sitting there ingesting all of my history into its context window, and it was eating up massive tokens every time. So that's now corrected, but it was definitely a lesson. Learning layer. This is really something that there's if you look at the sort of the social media on these bots right now, there are so many different people thinking about how do you do memory. I have arrived at a system that I think is pretty darn cool, and maybe if people are interested, I'll do a session on that. But what happens is that the memory is really, really important. What you find if you just use this bot out of the box is it'll say, oh, I don't, that session I don't really remember. It'll have to go back and do a search. You'll spend time dealing with that. It's how do you make sure that it has rapid recall for the things that are really important, and it ignores or sort of processes out the stuff that isn't. And that's something that I haven't perfected yet. I don't think anybody has, but it's really it's a super interesting technical problem, and and I do have some ideas on it. And then finally, this one is just crazy. Prompt injection is a very real problem and has to be considered as part of any solution that you do. And so, so those are things, these are sort of the lessons learned so far and the lessons that are going into my open source project. So really, right now, the ecosystem isn't ready, right? If you look at OpenCloud, it's got massive bugs. There's functionality gaps. There's all kind. I shifted away from it for that reason. Um, but I do think, as a chief AI officer, we need to be tuned into these topics because the conversation is going to come up. Even if the conversation is, "Hey, I'd love to do this. How do we get this done?" And you're telling them no. It's important to understand these principles. And then finally, just open it up for. I did leave some time for questions. That was my goal. So with that, are there any questions?
There are some questions indeed that I have collected. And then I also see Joel, I see you. Real quick, I'm just going to run through some of the questions that I collected previously, and then I'll, if anyone wants to, who asked a question wants to come off mute, we can. And then Joel, I got you. Oh, and then Victoria, I just saw your question as well. I'm going to add that to the list. Okay, so Steve, I'm just going to pop them all in the chat as well, but I'll read them out to you so that just for ease for everybody. The first question was from Mark. Where do you cover logging of activities?
Okay, and the answer to that one is it's covered in multiple layers. Okay, so the basic logging, so the basic logging in my bot, I'll just focus on blastr because that's the one that I sort of know pretty well. It's logging all it logs a bunch of stuff in the syslogs on the machine. So one of the features of Bastion Claw is that every agent spins up its own container. And so there's a whole transaction history in Docker that I need to look at. The second one is that all the session history is saved, and that's at a different layer. But then there's this third layer, and that's Watcher. And Watcher actually is collecting telemetry from the various agents. It's collecting, it's looking in certain spots for different things. And it's also constantly taking all of that information and aggregating it and analyzing it for threats.
Okay. Thank you.
The next question is also from Mark. And it was, sorry. Steve, how do we evaluate the validity of shared skilled from third parties?
Ooh, yeah. Okay, so there are now tools out there that you can use that will scan stuff. But I want to say that with a caveat. So first of all, most tools consist of either consist of a markdown file that'll call some code, et cetera. Now, when you're looking at that, right, that markdown file is easy to read. It's just human English language. You can see when it's calling for something. The tricks that come up are, let's say that thing makes a web call, an internet call, right? Got to check that out. Let's say, and if there's code, then it's really important to run that through some sort of a SAST scanner. But if you're interested, just drop me a DM and I'll look up there are a couple of tools that I've heard of that are better than others for scanning before you bring something in, and you can actually automate the scan. If you're using, depending on the tool you're using, there's a function called hooks. You can actually implement your CI/CD pipeline in hooks, and you can actually automatically scan things that come in. You can do it in GitHub too if you want. So there are different ways to do it.
Okay. And so okay, so because what I'm looking at is I'm seeing an ongoing quote unquote marketplace of these things. And so I'm looking at saying, okay, don't don't install those skills as they're calling them because you don't know who's behind it. And I've seen some people intentionally do it just to demonstrate what's actually happening when you do that. It's kind of tongue in cheek, but somebody will have a skill that goes to a website that then automatically publishes a testimonial on behalf of the person, and they're like, "How the hell did that happen?" You need to understand that it's kind of
Well,
like
and,
macros and
and
things and stuff. So
what I do as a best practice is I build my own skills.
yeah,
And
yeah,
so in the age of like, and I know I constantly talk about Claude Code. That's the one I use. But if you use Antigravity or one of these others, do the same thing. What I'll
yeah,
do is I'll find a skill that has something that I like, and I will use Claude Code to analyze that and analyze the method, analyze what is the method that it uses. Make sure that if you're doing that, though, you prompt it to not execute anything,
yeah,
that that this is considered external content and it's untrusted.
yeah,
But once you've analyzed it, then you can just rebuild it in 15 minutes with Claude Code. So
yeah,
but those marketplaces, there was a, like, right when they first popped up, there was a big article about how more than 60% of the stuff on there was infected, was infected in one way or another.
yeah.
Those Some of the marketplaces have implemented scanning of different types, but I would still just exercise caution.
Perfect. I've sent you a couple emails. Did you get those by any chance?
Yeah, let me take a look.
Okay.
I'll follow
After
back
the
up with you
call.
offline,
Yeah,
Mark.
after the
Yeah,
call. Yeah, I've got some things I'd like to talk to you about and potentially
definitely.
some work for you. So
Yeah,
thanks.
perfect.
Okay. Appreciate great session.
Yeah, thank you.
Um, question from Phil Gregory. Are the use cases Steve talks about based on his experience building AI systems for customers, or are they based on the company he's working for?
Okay, so well, right now I'm not working for a company. I'm an independent consultant. I have the answer is yes, but is yes that both I've built them for customers, but I've also done a lot of experimentation. I don't know if I would, to be honest with you, if I would implement blastr for somebody if they asked. I mean, it's been an incredibly useful learning experience. But man, there is, I did consider for a moment building sort of these boxes that I could sell to people with personal assistants on them, and manage it. And it's just there's a lot of risk in that. Um, but again, yeah, I mean, it's definitely something that I've considered.
Great. And then, okay, so now we're gonna go quickly to Joel because he was in the queue, and then I have a few more questions from that I've collected from Victoria, Anthony, and Allison for now.
I think my question will answer Anthony's question. When you first started on this presentation, you showed us a pretty complex diagram of blastr and
Mhm.
all the subagents that you've created. Uh, Anthony, and my question were is did you, and I think you answered this during the session. Um, I think that you probably went in and created every single one of those agents on your own, linked them together. But my original question was, did you use like Claude Cowork to build these without going in and individually building them?
So
Which
yeah,
is the
so
correct method you took?
Yeah, so here's how I do it. And this actually maybe the next time when we talk about Claude Code, I'll go through what my process is.
Yeah.
I actually use Claude Code. So I start by using it as an ideation tool, right? I say, this is what I'm thinking about, and in this case, right, basically what I had kind of a description of what blastr was, and here are all the use cases I want to use. And I said, okay, so help me ideate help me ideate these things. And it helped me build out each one of those use cases.
Yeah.
And then I said, okay, go take that and translate that into a build specification for each one of those, and a migration plan or a deployment plan. It did that, and then I basically said, actually because I'm sort of a control freak, I said, I went through one by one and said, build this one, build that one, build this one, build that one,
So
right?
it was a little bit of both. It was a little
Yeah,
bit of Claude
Yeah.
work, doing some of the, like, you need an archivist.
yeah,
This is what
yeah.
should go into that archivist, and then you went and said, okay, build it, but I'm going to check it before I let it roam.
And here's the thing, there's a
That's good.
trade-off when you're doing that. You can do it much, much quicker and with less hassle if you don't want to specify exactly how the thing works, right? For some of them, like the connector, right? I'm really particular about how I want that CRM to look. So I was really careful on that one, right? Watcher was a lot easier because I could just feed it a bunch of security documents, say, this is what I want, just build that. So it was, but yeah, I mean, this one has been, and I think if I was going to do it again, right? There's when you're building stuff in the age of agentic, there's always this trade-off between how deterministic you want to get and how much leeway you give it.
Yeah.
And there are people that just give it, all kinds of leeway, and they end up with, less predictable results. And that's sort of where that's
Yeah.
sort of my
Just to,
thinking on it.
Steve,
just to
thank you.
piggyback on Joel's.
Steve,
Go ahead, Joel.
I was just going to say, Steve, thank you. I've got to drop off to get on to Eaton's
Yeah,
call.
and reach out. I mean, I'm happy to share documents. I
This was
can
awesome.
show you some of these plans and things, and it's but this is how I did it.
Thank you. Go ahead, Anthony.
Yeah,
Thank you.
yeah, appreciate it, Joel. Thank you, Steve. This has been really great, Steve. I really, it's funny because I just drew out I've been playing with OpenClaw, and I drew out my entire schema yesterday and started thinking about these lines and how they connect. About and it's fascinating. I love the way you've connected these things. And uh, did so your
So
process?
one tip,
Yeah,
right? Start with hub and spoke.
hub and spoke.
Don't worry about all these connections initially. Start with hub and spoke, and then become more efficient. And also, you're going to find you're going to run into some severe bugs in OpenClaw when you try to do this. So there are better tools out there.
Yeah, no, I've experienced the severe bugs because I've been building this slowly and implementing all these de-risking things, and it's been taking forever. But the some of the key pieces, because I have like a source, I've named mine Sourcey, trying to build out different marquee for marketing, Sourcey, consulting.
I did the same things, yeah.
And so they're same things, but it's so I love the way how you frame these different buckets. Do you have a more of a descriptor for each of these in terms of have you really created a
Yeah, I
markdown file for each?
do. I mean, I can provide that to you. I don't have it in the stack, but yeah, I could do it. Yeah, I mean, each one of these really, this is sort of version 2 of this architecture for me. And really what I decided was, I mean, each one of these has a very well-defined role.
Yeah.
Okay, so it does very specific things. Now they do work together, right? One of them does its thing in its role and then passes to another one.
Mhm.
For example, I might have, I'll have like the artisan create a bunch of images, or the scribe says, I need an image for this, passes the job to the artisan builds it and puts and sends it back.
Mhm.
But each one of these is very specific, and it's built around, they're limited. Again, I've eaten my own dog food, right? Been careful about the tools that they use and how they access, what access they have to each other and that sort of thing.
Mhm.
Now, did I need that level of security for a personal bot? Maybe not, but it's been a very useful exercise.
Yeah, I mean, it's impressive because I mean, I'm just thinking for the scheduler, for connecting Calendly and all these different pieces, each one of them is integrated with different technologies, and
And
understanding that
and
entire paradigm for you is,
one other
would be
thing, and
awesome.
I didn't build an architecture diagram, but and we can geek out on this,
Yeah.
um, is how you do the memory layer and how
Mhm.
you control
Yeah.
access to the memory layer is really important, right? I had to build my own memory layer
Mhm.
on top of the things. Now, what I did do, the bot that I'm using, this Bastion Claw, has a memory layer already called QMD. But QMD is good for recall of things. It's not necessarily good for making mental connections between things. And so I've kind of built a knowledge graph layer on top of that. And what I find is really freaking cool. The So just to, I mean, I'm just to give you an example, right? If you know I'll be talking about, I'll talk to blastr about, okay, I'm going to go to the gym and work out, and it'll say, wait, but you have this on your calendar. Oh no, that got canceled. Okay, when did okay, and it searches, says, well, I see in your email that it was rescheduled, but it didn't go through properly. So do you want me to do that? Yeah. And it has become this immensely useful thing. That
Mhm.
memory layer plus, or that knowledge graph plus the learning layer is just been it's super super cool. And you want to
Nice.
be able to give certain access to it to the different sub agents.
Yeah. I'm glad you're doing the watcher too. That was a brand new concept for me, so I love it. Thank you, Steve. You're
Yeah,
awesome.
yeah, cool.
Okay. Victoria asked what you did. Hold on, I have the exact thing. Um, Steve, what program did you use to create this presentation? It's nice and clean.
Yeah, I love it. It's called gamma.app.
Great.
And it is, and the key thing, so I usually will generate it has an AI thing that generates the slides. I usually generate the AI thing, the prompt for that in Claude. And when you do that, the problem with Claude is that it becomes very chatty. So you've got to tell Claude to cool it. But it comes out with some really nice results. I would prefer it. I'm still working on it to try to get my stuff simpler. But that's, because it tends to create crazy stuff. But I love having this ability because I'm an engineer. I'm no, I'm fully in my left brain. I'm not creative myself, so.
Excellent. And then let's see. Pardon me, the chat bops around sometimes.
I see one asking if I've shared the presentation. I will. I haven't done it yet, but I'll send it to you,
Yeah.
Alex, after the call.
Oh yes, okay. Allison, but I'm not sure. No, Allison's not still here. So her question was, do you know anything about Claude Code security that Anthropic recently announced? I can't tell if it's basically something that we could just build ourselves with skills, or if it's a true packaged product that is more secure and reliable, especially for enterprise level deployments.
The answer is both, and tune in next week. That's my topic.
Okay, great. And then, yeah, other than that, people shouting out all of the awesomeness. If
Oh, I
anyone
appreciate
else,
it,
of
guys.
course, has anything else they want to share, please.
One more point. If anybody's got a topic that I mean, I will, I've got about 3 or 4 weeks lined up at this point. I'm happy to go into things, especially if it has some sort of a connection to governance, privacy, data privacy, or cybersecurity for around AI. So this is great. This is stuff I love to do.
Yeah, well, thank you. I mean, Steve, thank you so much. I mean, everyone was just really grateful for, I think, such a vital aspect of all of this. Um, I've attached really quickly for the short feedback form. I'll be sure to get, all the information, the recordings and the resources up. Steve, if you don't mind just dropping the
I'll
slide
I'll
deck
do
for
that
me
afterward. Yeah.
anytime, that would be awesome. And otherwise, thank you. Oh, Mark, you have your hand up. Go ahead.
Yeah, Steve, real quick, you mentioned Bastion Claw.
Yes.
What is? I'm
You know
looking
what?
for it. I
I'll put
can't
it
find it.
into this one is actually a project that's run by a friend of mine. It's on top of NanoClaw. This guy he builds a bunch of stuff into it. Let me put it in the chat. But it's and I've customized mine a bit, but it's more secure. Where did I put that? Yeah, I'll put that into the chat, and look this guy up and give him some stars. He's doing a great job.
And this is what you build blastr Junior on?
This is blastr Junior. Well, it
Yeah.
did it share? It says error. Enter to send. It's not entering. All right, hold on.
Oh, it's going to the waiting room. That's why.
There it is. Okay, should be there. No, didn't.
No, it's in the waiting room.
Oh, I'm in the waiting room. Sorry, everyone. No participants in the waiting room. All right, you know what? I'll post it. I'll post it for everyone. I'll give it to Alex and she can get it out to everybody.
Absolutely.
All right. Well, thank you very much, everybody. I'll feel free to reach out.
Definitely. And Anthony, let me see what the answer to that question. Let's see.
Yeah, I didn't see the de-risking agent
Yeah, it is
on
not
here.
here.
So I want to make sure
So
I can give feedback.
honestly, put anyone and then in the additional comments indicate the actual name of the thing.
Okay, will do.
Yeah,
Thank you,
thank you
Alex.
so much. And I'll
Thanks
let
again,
them
Steve.
know that they need to update that as well.
Okay, appreciate it.
Great,
Thanks,
thanks.
everybody. Really appreciate
Thank
it.
you. Thank you.
So cool. Talk to everybody soon.
So, Toy, yeah. I ended the recording,
Yeah, I think Steve.
but I think Steve left.
That's all right, man. I was trying to catch both Alex, gosh, Allison and Steve, and
And
then
then
Allison jumped to Aton's meeting, and
okay.
well, I'll have to
Yeah,
catch them some other way.
I bet you will. They'll be lucky to have your attention. Um, I know I am. Can't wait. Okay, yeah. So I'm gonna give another 30 seconds, everyone, then I'm gonna close this meeting, I guess. Thank you all so much for everything. Looking forward to seeing you again in the space.
See you later, Alex. Bye, everybody.
Bye.
We're still listening. Bye.